Hi everybody, welcome to physics teacher classes. Today we are going to discuss derivation of equations of motion with the help of graphs. What is that? Derivation of equations of motion. Equations of motion with the help of graphs. Okay, by using graphs we are going to derive this. Come on. Yeah, first consider an object is moving in a straight line with an initial velocity u, and after time t seconds its velocity is v, right? And acceleration is uniform acceleration. So at a time 0 the velocity of the object is u. After time t seconds its velocity is v. Now let us draw vt graph for this. Time is taken on x-axis, velocity is taken on y-axis. Now it has the initial velocity z, u, it's not 0. Okay, so then how will be our graph? Our graph starts here and this is the graph. Okay, so this is how much? The value is u. And what will be this value? V. And how much is the time? T. Right? No, this is the graph. Yeah, first equation of motion let us calculate. So first we will be calculating slope of the graph. What is that? Slope. We know that slope of vt graph gives acceleration. Yes or no? Therefore acceleration is equal to, what is that? Slope is y2 minus y1 by x2 minus x1. Yes or no? Yeah, that is equal to y2 on y-axis. What is the second value? V minus y1 is u divided by x2 is t minus x1 is 0. Clear? Then this is equal to v minus u by t is acceleration. So do cross multiplication. At is equal to v minus u, and this side v is equal to u plus at. This is our first equation of motion we learnt. Yes or no? Yes. Clear? What we have calculated? We have calculated slope from the graph. Then we got this. Now second thing, I am going to calculate area under the graph. Okay, I know that if I calculate area under vt graph, that gives displacement. What does it gives? Displacement. Yes or no? Now displacement is equal to, see here what I told, area means up to time axis we need to calculate. See this whole area we need to calculate, the shaded region, whole area we need to calculate. Right now this I am going to divide into two. One is a rectangle, another one is a triangle. Okay, then area of this total is first area of the rectangle plus area of the triangle. Now what is the area of rectangle? Length into breadth. What is the length? T into what is the breadth? U plus area of the triangle, that is half into base into height. Half into what is the base? T into what is the height? Height means this is, how much is this? This is v minus u. V minus u. Okay, no. Now this is u into t, ut plus half into t into v minus u. What can I write? V minus u. From this v minus u is equal to a into t. Yes or no? Then I can write at. Then this will be is equal to ut plus half a t into t, t square. This is our displacement. Second equation of motion. Yes or no? Very simple. See, such a easy from the graphs. We have calculated slope, we have calculated area, we got it. Right, now let us see third one. For third one we will be using average velocity formula. So actually what is average velocity formula? Total displacement by total time taken. Yes or no? And now this is equal to, displacement is equal to average velocity into time. Can I write? Displacement is equal to cross multiplication, average velocity into time. Now here velocities v and u. What is its average mathematically? V plus u by 2. This is the average velocity into time. Okay, Nana? Now from this, what I am going to write is S is equal to v plus u by 2 into, in place of t, okay, what can I write? V minus u by a. Can I write or not? In place of t, if t goes here, a comes here, v minus u by a. Clear? Yeah, now let us see this one. So that is equal to v plus u into v minus u by 2 into a. 2a is our displacement. Now do cross multiplication. 2as is equal to a plus b into a minus b. Very good. A square minus b square, that is u square minus v square. So this is our third equation of motion. How simple? Yes or no? Right, now let us see how to derive nth second distance traveled by the body. Okay, that means we are going to derive Sn is equal to u plus a into n minus half equation. Right, Nana? So see here, suppose a body travels s distance, okay, in n seconds. Okay, now in n seconds the body travels this much distance, yes. Clear? Then in n minus 1 seconds, this is the distance traveled by the body. This is the, let us take this as s1 and this as s2. This is in n minus 1 seconds. Understood or not? This is up to n. Okay, this is n minus 1. Simply, this is in 4 seconds it has traveled. In 3 seconds, this is the distance traveled in 3 seconds. Similarly, in n seconds is this. In n minus 1 seconds is this. Means see 4 minus 1, 3. Now what about this? This is the distance traveled in nth second. Am I correct or not? Okay, now this is the total distance traveled in n seconds. S1 that is. This is the total distance traveled in n minus 1 seconds. Then what about this? Distance traveled in nth second. How do I get that? S nth is equal to S1 minus S2. Can I write? Sn is equal to S1 minus S2. Clear? Right. What is S1? Distance traveled in n seconds. That is what? Un plus half a into n square. Ut plus half ad square. Right, Nana? Minus, what is distance traveled in S2? Means n minus 1 seconds. That is u of n minus 1, ut plus half ad square again, plus half a of n minus 1 whole square. Clear? Right. So let me write this as un plus half a n square, okay, minus un plus u plus half a into a square plus b square minus 2ab. Okay, now then if you simplify that, you will be getting the equation u plus a into n minus half. Just to simplify that, this is our distance traveled in nth second formula. Clear, Nana? In this way, one can very easily derive equations of motion from the graphs. Got my point? Yeah. Clear? Very good. Now let us see some more important points regarding graphs now. So first of all, let us see on graph, distance time graph. Okay, this is time and distance time graph. The shape of the distance time graph is this. Okay, the distance time graph is this. What information can we get from this? Okay, now that we are going to learn now. What information does it tells to us? Now let us see first, what about the slope of the graph? Okay, slope is nothing but what? Tan theta or theta. Okay, so is theta greater than 90 or theta less than 90 degrees? Let us see. Okay, what sir, if theta is greater than 90 degrees? Okay, so if theta is greater than 90 degrees, then slope is, listen carefully, then slope is what? Next, if theta is less than 90 degrees, what about slope? Clear? Right now, so if theta is less than 90 degrees, slope is positive. If theta is less than 90 degrees, slope is positive. Slope is positive. If theta is greater than 90 degrees, slope is negative. Remember this point. Okay, so if slope is negative, velocity is negative. Okay, now because slope is nothing but the velocity. Right now, slope is positive, velocity is positive. Clear? What does it implies? It implies that velocity is negative. It implies that velocity is positive. Understood everyone? Yeah, now let us see slope. What is this? This is the slope of the graph. Okay, now this is the angle. Now tell me, is this slope means theta greater than 90 degrees or less than 90 degrees? Yeah, it is greater than 90 degrees. Therefore, slope is negative. Therefore, velocity is negative in this case. Understood? Okay, so slope, if the graph is like this, slope is theta is greater than 90 degrees. If the graph slope is like this, then theta is less than 90 degrees. Remember that. This is forward slash backward slash. Okay, so when you draw tangents, you get in this way backward, then that is theta is 90 degrees. When you draw forward, then theta is greater than 90 degrees. Now see here, now we got velocity sign, right? What about is it increasing or decreasing? Is the velocity increasing or decreasing? Now see that with x-axis it makes theta angle here. What about here? Here also theta. What about here? Here also theta. Therefore here theta is constant. That means what? Slope is constant. Yes or no? Therefore velocity is constant. Okay now, so we got two things here. One is velocity constant and it is positive or negative. See that theta is greater than 90 degrees. Then velocity is negative. These two things we observe from this. Velocity is negative, okay, and it is constant. Clear? Yeah. Then what could be its velocity time graph? Time velocity. See, velocity should be negative and constant. That means somewhere here. This is the graph, corresponding graph. Understood? Clear enough? Yeah. Let us see one more thing. Try to understand the things, right? So let us see one more ST graph now. Displacement time graph. Now the shape of the displacement time graph is a curve. Already you have seen, if displacement time graph is this curve, it is accelerated motion. Now let us see whether it is accelerated or retardation. What are the things? Okay, and now let me draw slope for this. How to draw slope? Okay, so you draw tangent. First at this point you draw tangent. This is the tangent. At this point you draw tangent. This is the tangent. At this point you draw tangent. This is the tangent. Okay, now these are the angles, means slopes. Okay, is this angle theta less than 90 or greater than 90? See this, forward we have drawn, yes or no? Then theta is less than 90 degrees. When theta is less than 90 degrees, slope is positive or negative? Very good. Okay, slope is positive. That means velocity is positive. Clear? And next thing is velocity constant or increasing? Okay, in the previous case velocity is constant. How did I say? As the slope is constant. Now see here, theta 1, theta 2, theta 3. How is theta increasing or decreasing? As the time increasing, theta increasing. Yes or no? As t increases. You observe carefully. As the time increasing, at this point this is the slope. At this point this is. At this point this is. Okay. Theta also increasing. Clear? Okay. As the time increasing, theta also increasing. This means velocity increases. Or velocity increasing. Understood, Nana? So we got what? Theta is less than 90 degrees. Slope is positive. Slope positive means velocity is positive. We got one conclusion. Now check whether the velocity constant or increasing or decreasing. How? If the theta increasing, velocity increases. If theta decreases, velocity decreases. If theta constant means slope constant, velocity constant. In previous case that is. Here velocity is increasing. Okay. So as velocity is increasing means which kind of motion is this? Right. Accelerated motion. Okay. Then this acceleration is positive or negative? Positive. How I said? Velocity is increasing. Okay, na sir? Then this motion is what, Nana? Accelerated motion. What motion? Accelerated motion. Clear? When ST graph is a curve, upward curve, see this. Okay, na? Then these are the things we can draw from that. Clear? Now let us see one more thing. Okay, one more graph let us learn. So that is ST graph is like this now. So displacement time graph is this. Then the shape of the graph is drawn in this way. Suppose. That's okay. So this is the graph. Which graph? ST graph. Okay, sir. Now let us draw the conclusions. First, let us see its slope. Is it greater than 90 or less than 90 degrees? So how? Draw tangent. So at this point you draw tangent. At this point you draw tangent. Okay. See that is theta is increasing or decreasing? Sorry, less than 90 or greater than 90? Theta is less than 90 degrees. We are drawing in this way. If you draw in this way, theta will be greater than 90. Right, Nana? Yeah. So in this case, theta is less than 90. Theta is less than 90 means what? Very good. Slope is positive. Okay. Slope positive. Slope positive means velocity also positive. Velocity positive. Now see that as t increasing, okay, as time increasing, what about theta increasing or decreasing? As time is increasing, what about theta? Observe carefully. So at this point if I draw, this could be that. Okay, theta is decreasing. Yes or no, no? As the time is increasing, theta is decreasing. That means what? Velocity increasing or decreasing? Very good. Velocity is decreasing. Velocity is decreasing. Then which kind of motion is this? Acceleration is positive or negative? Negative. Then this kind of motion is what, Nana? Retardation. Very simple. Yes. See this? Slope. Theta is less than 90 degrees. Okay. Slope positive. So that velocity positive. Next, is it increasing or decreasing? Let us see. As the time is increasing, theta is decreasing. So that it is decreasing. So the motion is what? Retardation. Clear? Yeah. So how to remember these increasing or decreasing? Are there any shortcuts? Yes, there are shortcuts. Listen carefully. Right? So you follow these shortcuts, within minutes you can tell the answers of questions given in different competitive examinations. So if the displacement time graph, the shape of the graph is curve upward. If it is a straight line, there is no acceleration. If the ST graph is a straight line, there is no acceleration. If the ST graph is curve, then is acceleration. Now it is upward curve. Okay, so as the displacement time graph is upward curve, what you need to remember is acceleration is positive. Acceleration is positive. Okay, na sir? Next thing. So if the displacement time graph is a curve downward, okay, it's a curve downward. What does it mean? It means that acceleration is negative. Acceleration is negative. Okay. Regarding accelerations, if the curve is upward, acceleration is positive. If the curve is downward, acceleration is negative. Then what about its speed, whether it is increasing or decreasing? Yeah, that also there. Okay, shortcut is there. So if velocity and acceleration, okay na, velocity and acceleration both have same sign means positive or negative, okay, then speed of the body, okay, speed of the body increases. What happens? Increases. Okay na? When V and A have same sign. Next, when velocity and acceleration have opposite sign. What is that, Nana? Opposite sign. Then speed of the body, what happens? Decreases. Very good. You got it. Okay, just to remember these shortcuts. Okay, clear? Right, if ST graph is upward curve, acceleration is positive. Clear? Positive. If the ST graph is downward curve, acceleration is negative. Okay na? You can remember or not? Yeah, very easily. Next, V and A have same sign, speed increases. Velocity, acceleration, same sign, speed increases. Velocity and acceleration, opposite sign, speed decreases. Okay, just to remember this, you can solve lot many by using this. Okay, let us see one example. Okay, so I'll prove it whether these are easy or not. Now let us see one more example to understand it very easily. ST graph. Suppose the ST graph is this. This is the shape. Okay, now tell me, this is a curve. So curve means acceleration is there. Is the curve upward or downward? Very clearly it is upward curve. Therefore acceleration is positive. No doubt. Okay, no. So as the curve is upward, see, is it moving upward or downward? Upward. So acceleration is positive. Now what about velocity? Is velocity positive or negative? How do you get velocity? Depending on theta. See, you draw a tangent. At this point, I draw a tangent. Okay. So this is the theta. So theta is greater than 90 degrees. Theta is greater than 90 degrees means velocity is negative. Yes or no? How simply we are drawing, see that. What about acceleration? Positive. Velocity? Negative. Are they in same sign or opposite sign? Opposite sign. One is positive, another one is. Therefore, what is its speed, sir? Speed decreases. Finished. Okay. By understanding, by observing the curve, you can say acceleration. Just by drawing a tangent, you can say velocity. If you observe the signs, you can tell speed. How simple. Yes or no? So for our practice, let us take one more. Yes, sir? Yeah. So let us see one more. Just for practice. Practice makes man perfect. We know that. Now the curve is this. Shape of this curve. Now tell me, it is upward or downward? Yeah, downward. What about acceleration? Acceleration is negative. Simple. Okay. Now theta. Okay. So just you draw a tangent to this point onto the time axis. Okay. Is this greater than 90 or less than 90? Greater than 90 degrees. Okay. Then greater than 90, what about velocity? Velocity is negative. Okay. See that this is negative, this is negative. What about speed? Speed increases. How simple? Very easy. Yes. Let us see one more. Yeah, come on. You got the concept. Okay, distance time graph. Now the distance time graph is, this is. Now tell me, is it upward or downward? Upward. Curve is upward. So acceleration, positive. Okay, now theta. Draw a tangent to this point, or any point you can draw a tangent. Okay, now this is. So is theta greater than or less than? Less than 90 degrees. So speed is positive or negative? Come on. Positive. Okay. Now what about the speed? Increasing or decreasing? Speed increases. Okay, no. Very easy. Can you draw VT graph for this? What could be VT graph for this? See, velocity positive and increasing. Velocity is positive and increasing. This is. Right, Nana? Very simple. In this way, you can draw you can solve lot many problems on this. So this is about graphs. So with this video, we are concluding the graphs. Right? So please subscribe my channel and share it to your friends so that we can reach to all members of Physics Society. Thank you very much.